So, last class, we talked about completing the square. We're going to start with just finding the value of C, and this is what's going to happen when A is not 1. So the first thing we're going to do is going to factor out the GCF of the terms with the H, and not the complete GCF. We just want the number in front. We want to force the A value to be 1. So here, I'm going to take out a 5. When I take out a 5, I'm left with x squared minus 6x. Go like this. And I would be saying equal to whatever happens to be the number. For right now, I'm going to say 0, because we always move the constant number over normally when we do this. So now, in order to figure out what number, last class, to add to both sides, I took the -6. I divided by 2, and I got -3. When I squared it, I get 9. So I would add 9 here, and I would add 9 here. Big question, did I really add 9? What did I really add? Using my distributive property, I added 5 times 9, or 45. And that's the number that I add to both sides. That's my C value. So now I'm going to do the other one below it, and then you guys are going to try to. So over here, I'm going to factor out my 6. And when I don't have to worry about an equation, I'm going to kind of probably do it a little bit different. I'm going to say x squared minus 3x. So the number in front is 3. This is another first for us. When I say 3 divided by 2, I can't divide that evenly. So what do? I square it, and I get 9/4. So I would be adding 9/4 here, but really what I'm adding for my C value is 6 times 9/4. And I can reduce that. I can take a 2 out of both, and I end up with 27 halves. That's what I add to both sides. So what I want you guys to do now is I want you to try the other two, and we'll put up the answers in a second. One of the things we're going to do differently that we didn't do yesterday, hopefully, yep, there we go, moved up, is we're going to actually graph these. We're going to put them in vertex form and graph them. This is why I like vertex form. It's the easiest thing in the world to graph, and I can get it done pretty quickly. So if I look at this one, I would say 2x squared minus 4x equals -5. That's what I did last class. Nothing new yet. Now I'm going to force my A value to be 1 by dividing everything by 2, or factoring out a 2 in this case. Everyone following along so far? Now, I take this -2, I divide by 2. I get -1, and I square it, and I get a +1. So I'm going to add 1 here. I don't add 1 to the other side. I add 2 times 1, or 2, because of the distributive property. This 2 is still on the outside. It never changes. When I factor, it's x minus 1. And I get the -1 from right here before I square it. Equals -1. 5 plus 2, actually it's negative, I can't add, I don't know where I'm getting 1. 5 plus 2 is -5 plus 2, sorry, -3, thank you. See, I put 1. I don't know where I got that. I move this over and I get 2x minus 1 squared plus 3 equals y. This is my vertex form. What equation above it? This one? This one right here. That's what I started with. All I did was I took this 5 and I moved it to the other side. Because I know I'm going to add something. I always end up leaving a space there. When I'm completing the square, I'll leave a space. I left it here and I filled it in. Now, if I want to graph it, this is where this becomes fun. My vertex is 1, 3. 1, 3. My A value is 2. That tells me if I go to the right 1, instead of going up 1, I go up 2. And left 1, up 2. That's how I find my A values. Now, if I want to know what my next point is, in my parent function, when I go 2, I go to 4. Does everyone agree with that? 2 squared is 4. Now, instead of being a 4, it's going to be an 8. So from my vertex, I go over 2, up 1, 2, 3, 4, 5, 6, 7, 8. With my axis of symmetry, that tells me here's the other 8. And then I graph it. I missed, sorry, my pen's a little off, but you get the idea. It's going to be a U. I know that since A is positive, my range is 3 with a bracket all the way to infinity. My domain is negative to positive infinity. My x equals 1 is my axis of symmetry. As x approaches positive or negative infinity, y is approaching positive infinity. I know all that stuff just by looking at this graph, and this did not take that long. When I start with up above without a graphing calculator to graph this 2x squared minus 4x plus 5, I have to make a table of values and plug in a bunch of stuff. I think this is a little easier. Also, if I tried to solve this thing, since that's a -3 from jump, I know I can't do it. I get an I. Take the square root of a negative number, you get an I. This has no real roots. It never crosses the x-axis. I know a bunch of fun stuff about it. Okay, so let's do this one. Actually, I want you guys to try this one first. I'm going to give you a couple minutes. Okay, guys, go ahead and check your answer. You'll notice that since you're just seeing the answer show up and not watching me do it, it's a little bit weird, but I started by taking out the 3 because I want to force my A value to be 1. I left the blank spot, which is where this is. This is red 9. And I put 28 on the other side of the equals sign. I did that all at once. I kind of skipped this step over here that I had done last time. So I did that, and then I said, okay, well, -6 divided by 2 is -3. Squared is 9, so I have to add 9 to both sides. Can't just add 9. I have to add 9 times 3 because that's really what I added on the left side. After I distribute, I get a 27 there. So when I do that, I get -1. I move that +1 over here to the side. My vertex ends up being 3, 1. Because my A is a 3, when I go over 1, I go up 3. Notice I did move this a little bit. Right there is pretty perfect. Okay, so I go over 1, up 3. Over 2, up 12 because it's normally 4, 2 comma 4, like over here. 4 times 3 is 12. That's where I'm coming up with those numbers.
Do we have a parent function?
Of course we do. What is our parent function? It is. That's exactly what goes in the table. But what is the parent? It's it's y equals x squared. It's the u, parabola shape. And the table of values, just because you might want to see them, my parent function that I'm constantly using is this. That's my parent function. That's the one that I choose to use. That's what my parent function looks like. Mm-hmm. My parent is what? No, 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 no. I said, when you pay attention, right here, this coordinate exists on my parent function. And what I was saying is when I go over 2 spaces, I go up 4 spaces. When my A value changes, this does not change. I will always go over 2. But when my A value is 3, like it was in the last problem, instead of going over 4 or up 4, I go up 12, 4 times 3. That's what I was saying. And I think it had to do with a 2 over there, but yeah. So let's do another one. The only thing that's going to change is I'm going to make that A value negative is what I'm going to do. I'm going to do number 7. You guys are going to do number 8. And I am going to do what I just did. I'm going to do 2 steps at once. I think mathematically you guys should be able to handle that. I am going to take that -3 out. I'm going to be left with x squared. When I take a -3 out, this becomes minus 2x. I'm going to leave a space. I'm also going to move my -4 to the other side, making it a +4. So I did all that at once. Now I take -2. I divide by 2 and I get -1. I square it and I get +1. I'm going to add 1 here. But really, I'm not just adding 1, I'm adding 1 times -3. So the entire reason I complete the square is so that I can factor this into a perfect square trinomial. Copy my -3. 4 minus 3 is 1. And I get -3 x minus 1 squared minus 1 equals y. My vertex is 1 comma -1. 1, -1, which is right here. Now, my A value is -3, which means I'm going to go over 1 and down 3. over 2 down 12. And notice I have an axis of symmetry, so I can just mirror image those 2 points if I want, or go backwards down 3, backwards 2, down 12, and try to connect my nice U and not make it look like a V because it's so tight. So that's what it looks like. I could then go through and do everything we've been doing to these functions since school started, actually since Algebra 2 or FADA, really. Axis of symmetry is x equals -1. You guys, did I graph that right? No, what did I do wrong? I am going to completely cheat. Don't hate me. Oh, I can't slide this over. That makes it even worse. I wanted to just slide this over. I really wanted to just slide it over. I wonder if I can. I don't want to just move it. I want to just go like... I'll redo it. Oh, gosh. Of course I had to mess up somewhere. I hate messing up when I'm recording. 1, -1 is right there. Who cannot plot a point? Me. Okay, now that I've done that, I can go over 1, down 3. Yeah, but we didn't catch you. That's okay. That's because you assume that I'm right all the time because I teach math, which is not the case. And there you go. That's what it actually looks like. When I said my axis of symmetry is x equals 1, I looked at my graph and said, no, it's not. I did something wrong. My domain, negative, positive infinity. My range, negative infinity all the way up to -1 with a bracket. As x approaches positive or negative infinity, I'm going down to negative infinity. I think that's pretty much. And I have no roots. I don't cross the x-axis again. I don't think I've crossed the x-axis yet. So go ahead and try the next one. Okay, so I totally messed up doing this one. So this is supposed to be a minus, which makes that a minus, makes that a minus, makes that a plus. And this point changes also to 2, 2, 3. Okay, you guys, real quick, I went ahead and did this one. You can see I messed up the first time I did it. That's why I highlighted it again in orange, because I messed up and made that a negative somehow. Don't ask. I forgot when I factored out the -2 to change my sign. So yeah, sorry. And then I fixed it, but I fixed it in a different color because I'm recording, so people knew what I fixed. Okay, so here's the thing. On the quiz that you just took, right, 2 classes ago, I guess, it was, hey, what are my roots? And you guys, some of you put it in the calculator and hit calculate root and got me a decimal, and that was fine. Some of you just guessed and said, 3.5 and a half. That was wrong, yes.
Why isn't the 4 divided by 2 a
The This should be negative and this should be negative, which makes that still positive 4. I fixed it everywhere else. Sorry. That was my mistake. I just didn't fix it up there. If I wanted to solve this, that's what we're going to talk about next. We're going to do a couple of problems where I solve, so I would actually be finding these zeros that don't hit the axis really nicely. So that's what we're going to work on.
Wait. One more thing. Why is it x minus 2 instead of x minus 4?
Because I use this value after I divide by 2. I forgot to do what? Oh no, I think I did, but I think it disappeared when I was erasing stuff because I messed up. Because I had it there and then I just kind of. Okay, so let's solve some of these. So when I solve this, I'm going to say 5 p squared minus 2p, leave a space, equals 40. I am never going to move that 40 back over. Ever. I don't have to move that 40 back over because I'm solving. I'm trying to figure out what x is. So from here, I'm going to take this -2. I'm going to divide by 2, and I get -1. I squared, and I get a +1. I add 1 here, but I'm really adding 1 times 5, or 5. So I get 5. This is the magic that happens. P minus 1 equals 45. If I want to solve this, I am getting P completely by itself. What is my next step? I have to divide by 5 on both sides. I want to get the P all by itself. So I divide by 5, and I get P minus 1 squared equals 9. Now what do I do next? Nope, it's already squared. What's the opposite of squaring? Square root it. When I take the square root, it becomes a plus or minus. That's pretty important to note. These are U's. Normally they hit the x-axis twice, right? So that's what the plus or minus comes from graphically. I end up with 2 equations. I end up with, and I'm going to write over here, P minus 1 equals 3, and P minus 1 equals -3. I'm going to add 1 to both sides. P equals 4, or P equals -2. And those are my 2 answers.
We've completed life. Not yet.
So let's look at number 11. I'm going to go ahead and do that. I start by taking out my 3. X squared plus 4x, leave a space, equals 20. because I took a negative 20, I made it a positive 20. Now, what number do I add to both sides? I take the 4, because it's the number in front of the x. I divide by 2, I get 2, I square it, and I get 4. So I'm going to add 4. And then over here, I'm going to add 4 times 3. I factor magically, not really, but we're going to call it magic, equals 32. Next, I divide by 3. I'm not going to write that step out. I think you guys can get it. It's going to be x plus 2 squared equals 32 divided by 3. Leave these things as fractions. I can't reduce that. If I wanted to try, I could hit math, enter, enter in my calculator, and it would do it for me. It's going to give me 32 thirds. Now I take my square root. My favorite thing to do. When I take my square root, I have to remember my plus or minus. I am left with, and this is going to be fun, x plus 2 equals plus or minus the square root of 32 thirds. Now, if you were in Algebra 2, your Algebra 2 teacher is going to tell you, you can't have a square root on the bottom, right? Also, you can simplify the top. I really don't care. We can leave it. You're going to end up getting a decimal. You can plug it in your calculator anyways. I care about moving that 2 over, and x ends up equaling negative 2 plus or minus the square root of 32 thirds. And that's your answer. You can plug it into your calculator exactly like that and get 2 decimals, plus square root, minus square root, and it's going to be something, and you're done. The last one I'm going to do with you is number 13. I'm going to take out the 7. $19 plus 3, because I'm moving it over, gives me 22. From there, I take the negative 2, divide by 2, I get negative 1. Negative 1 squared is 1. I add 1, but I'm really adding 7 times 1. I get 7 v minus 1 squared equals 29. I'm going to divide both sides by 7. (29) divided by 7. Then I take my square root, giving me my plus or minus. So it ends up being v minus 1 equals plus or minus the square root of 29/7, or v equals 1 plus or minus the square root of 29/7. Once again, that square root takes up the whole fraction, right? It could have been, if I looked at the square root of 29 over the square root of 7. Your Algebra 2 teacher hates square roots in the bottom. They're going to tell you to do something called rationalizing. And this ends up being whatever 29 times 7 is. Right? I don't know what that is off the top of my head. I'm not going to do it. No reason to. And that's what they would put in as your answer. Whatever that big number is, square rooted over it. 32, square root of 32 over square root of 3. 32 is, I believe, 4 times 8. Actually, it's 16 times 2. So this is actually 4 square root of 2 over square root of 3. You guys see how fun and complicated this can get? Got to rationalize. Root 3 over root 3, 4 square root of 6 over 3. That's the same exact thing. Now, mathematically, if I'm being really honest, can you guys give me an estimate about how much that is? No, not really. Can you give me an estimate about, how about square root of 32 over 3? No, not really. Can I plug them in the calculator and get the same thing? Yeah, that's why I say I don't care. Don't worry about rationalizing or simplifying at this point. It's not gonna, but you can if you want to. Some people liked it. Now I want you guys to try the other three. I might put up the answers in a second. Just the answers. I'm gonna write down the answers, and when I do, you guys are gonna see that they end up being a little bit off, if that makes sense. They're gonna show up because I'm gonna pause it to do it. These answers, I'm gonna put them in decimal form, so you guys are gonna have to plug them in the calculator, make sure your square root stuff is right. So those are my answers. You're going to want to actually probably plug in the square roots, and that way I say you don't have to reduce them. You're going to do it to thousandths, so 3 decimal places. Whenever you take the square root, that's about right. You generally do about 2 to 3 decimal places, and then 14 ends up being a whole number. You guys have one more worksheet just like this. It almost mirrors it, right? Like you're doing the exact same thing. And then you have the homework that was attached to the packet last class that all of a sudden they have A values that weren't 1. So you guys have to do that tonight too. So both packets are due next class, and I am reserving to write to give you a quiz on completing the square next class. I'm not saying I am, but it might happen.